When Amina left her job at a car parts company to join a small materials analysis firm, she never imagined her work would land her right in the middle of 21st century geopolitics. Her first assignment seemed straightforward enough: map the supply chain of a single electric vehicle motor. But what she found wasn't just a collection of parts. It was a hidden world of obscure elements that you never hear about in school, elements that are quietly shaping our future. Inside the Eve motor she took apart, she found a small, dark, palm-sized object. It looked totally unremarkable, and it was surprisingly tough to break. Yet, this little magnet held the power to launch a full-size SUV from 0 to 60 miles per hour. This wasn't just a magnet. It was made of neodymium, praseodymium, dysprosium, and a tiny bit of terbium. These are rare earth elements, and together they form the most powerful commercial magnets on Earth. And it's not just EVs. These same magnets are crucial components inside military drones, missile guidance systems, wind turbines, and even the MRI machines in hospitals. Amina quickly learned that digging these rare earths out of the ground wasn't the biggest challenge. The real bottleneck was refining them. You see, only a handful of companies in the entire world have the technology to separate these metals from their ores, align their atoms just right, and forge them into these incredibly high-performance magnets. It's not about geology. It's about industrial capability. This single point of failure makes the whole system extremely fragile and incredibly valuable. Amina's research didn't stop there. She started looking into other materials and found the same pattern everywhere. Take lithium. We all know it's for batteries, but the new generation of batteries uses high-nickel chemistries. This completely changes the demand for not just nickel, but also manganese and graphite. Then there's gallium and germanium. These two metals are the key to high-frequency computer chips and advanced radar systems. And what about good old copper? It might seem boring, but it's becoming a major choke point for upgrading our power grids, building out AV charging networks, and expanding the massive data centers that power the internet. Platinum group metals are quietly enabling the next wave of hydrogen fuel cells and industrial chemical processes. Titanium and tungsten literally determine what a country can build in the aerospace sector, from commercial jets to advanced fighter planes. Every single one of these metals share two critical qualities. First, they are strategically necessary for modern technology and defense. Second, their supply chains are concentrated in just a few places, making them incredibly fragile. It was a classic recipe for long-term structural price pressure and a massive investment opportunity. By the time Amina finished her report, she realized she wasn't just studying geology. She was mapping out the next great industrial power shift. This wasn't just about rocks in the ground. It was about who could turn those rocks into the building blocks of the future. And for investors, this shift highlighted several key themes. First and foremost is refining and processing capacity. This is the real bottleneck. Countries are starting to realize this and are pouring billions of dollars into building domestic refineries for rare earths, battery materials, and semiconductor metals. The companies that will win big aren't necessarily the ones with the mines, but the ones with the proven, efficient processing technology. They're the ones who will capture the highest profit margins. The second theme is high-end magnet manufacturing. The demand for EVs, robotics, and defense technology is pushing magnet factories to their absolute limits. The most successful companies will be the integrated producers, the ones that control their own supply of refined rare earths and can turn them into finished magnets. Third, recycling and urban mining. Think about it. Old permanent magnets, used batteries, and discarded semiconductor wafers are packed with concentrated, high-value metals. Developing efficient technology to recover these materials isn't just good for the environment. It's going to become a major competitive advantage, drastically reducing costs. So how can an investor get in on this? Well, some are looking at critical mineral ETFs, which bundle exposure across the sector. But the real high-growth opportunities might lie elsewhere. Think about junior mining companies that have found and validated new deposits of rare earths or battery metals. Or consider the tech firms developing proprietary new separation and refining technologies. Even infrastructure companies building the facilities for this new industrial base could be huge winners. Finally, there's the defense and industrial angle. Any mineral that's directly linked to missiles, satellites, aerospace, or hardening the electrical grid is now getting massive government support. These subsidies and policy-driven investments are creating powerful demand that isn't tied to normal economic cycles. For savvy investors, this can create some very favorable conditions. In the final version of her report, Amina wrote a single sentence that her client underlined in bright red ink. The next century's strategic advantage won't belong to whoever owns the minerals, but to whoever controls their transformation. That conclusion was blunt, but it was dead-on accurate. Anyone can dig a hole in the ground and start a mine. But building up refining expertise takes decades of investment and knowledge. Perfecting magnet technology is a proprietary art, and producing defense-grade materials requires a level of quality and consistency that very few can achieve. The world has entered a quiet race. It's not for oil anymore. It's a race for the invisible elements that power our electric motors, our quantum sensors, our most advanced weapons, and the AI-driven machinery that will define the future. The investors who understand this shift early on aren't just speculating. They are strategically positioning themselves around the very foundations of the next industrial era. They're investing in the invisible backbone of our modern world. Thanks for watching. If you found this interesting, don't forget to like and subscribe for more deep dives into the technologies shaping our future.